As Matt mentioned, we do see IGA as being the next generation of FEA. I had a lot of experience when I was an FEA analyst of spending a lot of time not really doing engineering work, but just defeaturing meshes for nonlinear analyses. So on the left here, one of the demos we're going to be showing today will be a vehicle suspension subassembly with a the brake system. So this is a caliper. On the left is how I might have defeatured this geometry for a hex mesh for a nonlinear analysis. It took me about 20 hours to build this defeatured mesh, since all I had was the step file to come starting. And so removing fillets that were difficult to hex mesh is where I spent vast majority of my time. On the right is IGA, which is the future, where I don't have to worry about defeaturing my CAD geometry, and I can go right into running my analysis. So in this case, it took me less than a minute to prepare this model. Also on the right, we've actually shown results that we'll also cover in our demo. Well, what I want to point out is my stress concentration occurring here in my shoulder fillet, which is a fillet that I had removed from my hex mesh. And what that ends up doing from a traditional FEA standpoint is that then I have to go and after my analysis, after my simulation, I pull out, Shigley or Rourke and look at my stress concentration factors, determine, I've got all of these different fillets I removed. What do I think the max stress is in these fillets? When you can just run directly on the CAD geometry, that level of approximation is gone. I just know what my simulation would predict for my stress concentration on those features. So less time and more accurate. That was a single part, but one of the things that we're pushing towards are assemblies. Also, this is Coreform IGA for Abaqus. We are building an integration into Abaqus CAE. This is actually done through the custom application functionality of Abaqus CAE. And one of the things that it lets us do is you'll see in our demo is we can start to add new dialogues and buttons to the task pane into the existing modules. Again, with the goal of being to try to have as seamless of an experience for current Abaqus CAE users and Abaqus users as well. In addition to being able to use all of the traditional FEA tooling that you would use, like connectors, connector forces, preloads, contact and assemblies that you already have experience with. I do want to mention that the red mesh that you see here is how we visualize our IGA meshes in Abaqus CAE today. I have, just to make this picture more clear, I've used a much coarser mesh here than we'll actually use for the solve, but just so you can see the notion of what we're doing and why that simplifies the meshing process. So that's kind of like where we're at today and what we're imminently developing in Coreform IGA for Abaqus. But also at Coreform, we've spent 20 years really of development in IGA. IGA was proposed in academia in 2005 or thereabouts by Professor Tom Hughes. And we've worked for those 20 years to demonstrate that IGA can do all of these different kinds of things that people do in FEA and do them well. Included along there are like local refinement and adaptivity, element deletion and fracture, explicit dynamics as well as implicit static and dynamic. There's really anything you can do in traditional FEA, you can do in IGA because IGA is a finite element method. And so it's just a matter of implementation.